This is an Explain Everything about adding and subtracting fractions. And I do hope that you enjoy this unit of work. Look for the pleasure in it, young people. It's a very pleasant piece of work, and I'm sure that most of you will be quite competent at this. Just before I start, I just want to remind you about all the other resources that are available to you. Don't forget the textbook, the Alpha textbook, IXL. You've got your passwords for that. If you are stuck, go to YouTube, enter these keywords, adding and subtracting fractions, and you'll hear somebody else explaining the same subject, and things might just fall into place for you. So Google, YouTube, very good resources for you to enjoy and to help you along. This is a slide from the textbook, and it shows you how to add fractions with the same denominator. And just to remind you, young people, remember, in any fraction, if I can get this stylus of mine to work, any fraction, the top number is the numerator. I'm going to run out of space, numerator, and the bottom number is the denominator. I'm definitely running out of space there. And the way that I remember it, young people, is I always, the D at the bottom to me stands for descend or for down, which means at the bottom. So the denominator for me is at the bottom, and the numerator, which is the other word, is at the top. So just do remember that when reference is made to same denominator, different denominator, that's the number below the line in the fraction. This is a good strategy to use just right here, young people. If you have a look at this setting out that I'm circling just here, that when you add fractions, set out what you need to add. 1 plus 7, and you put the 12 at the bottom. That just tells you that you're not going to add the 12s at the bottom. That can be quite confusing, because some of you might go 1 plus 7 at the top of the line, and 12 plus 12 at the bottom. Of course, it's not that. And if you read the purple box, you just rewrite the denominator, but you add the numerators. So if you set it out like that, it's a great strategy, because you're not going to make a very common mistake. So do try and get into that habit. Read this slide and make sure that you understand it. Subtracting with the same denominator. Subtraction is the opposite mathematical operation to addition. So you do it exactly the same way, the same rules apply, except above the line, instead of adding the numerators, you're actually subtracting them. So have a look at that example just there. A good example. And again, you can see that if you set it out like this, if you went 4 minus 1 over 5, that's a good way to set it out. They've not done it here in the textbook, and that's going to give you 4 minus 1 is 3 over 5. That just prevents you from making that very common mistake of sometimes getting the wrong thing below the line when you work with your denominator. Have a go at these fractions at this exercise 7.06. This is where you cement your knowledge. This is where you cement and practice what you've done in the previous slide. So this is very important. If it's easy up at the top, 1A, 1B, 1C, young people, have a go at something like J, for example. I find that the J's are often the most difficult ones to do. They've sort of slipped those in at the end. So have a go at those and see if you can do those. And remember, if you can, don't carry on doing it. Write me a little note in your maths workbook and just say, Mr. Hell, I'm moving on. And that tells me you know what you're doing, you can do it yourself, and you're carrying on. This is where adding fractions becomes a lot of fun. A lot more fun, in my personal opinion, because there's just a little bit of a challenge into it. You've got different denominators, so you have to remember your strategies for changing your different denominators into the same denominator, in other words, creating equivalent fractions. And then you are able, as I always say in the class, you can add apples to apples. You can't add apples to pears, and if your denominators are different, then you've got apples and pears. So until you've changed the denominators to something common to both, you can't add them. So do remember that. Read the purple box, young people. You must must remember what it says in there. Those are the instructions. You've got to commit that to memory. Write that down. To add fractions with different denominators, here are the steps. Change the fractions to equivalent fractions with the same denominator. Add these equivalent fractions and simplify if possible. I would recommend and prefer that you use this first example just here, young people. I see that I've covered over some of the writing there, but I've covered over that first fraction, but I'm going to delete my box now. But use this strategy where you simply, when you look for your common denominator, you're simply multiplying the two denominators, and you are getting 3 times 5 is 15. There is another option for you just here, but unless you're comfortable with that, just go this route initially at least, and multiply your two denominators together. You'll get a number that both of them can divide into. And remember, I always say, looking at the very first example just here, what did I do to 3 to give me 15? Well, I multiplied it by 5, so I have to multiply 1 above the line by 5. Looking just over here, what did I do to 5 to give me 15? Well, I multiplied it by 3 to give me 15 below the line, so I have to do the same above the line. So doing that's going to give me 3 above the line, 3/15, and 3 plus 5 above the line is going to give me 8, and the denominator 15 doesn't get added. I just rewrite that at the bottom, so there's a good answer. Remember that subtraction is the opposite mathematical operation to addition, and so we do it exactly in the same way that we added fractions, except instead of adding above the line, we actually subtract below the line. So very, very, very important that you read the purple box and you commit that to memory, young people, and you get so much practice in doing examples that it becomes second nature. To subtract fractions with different denominators, change the fractions to equivalent fractions with the same denominator, subtract these equivalent fractions, and simplify if possible. So, having a look at this example here again, I suggest that you simply multiply the 6 by the 10, and that's going to give you 60 below the line. And then you have to ask yourself, what did I do to the 6 to give me 60? Well, I multiplied by 10, so I've got to do that above the line. What did I multiply the 10 by to give me 6? I'm playing little lines here, young people. What did I multiply the 10 by to give me 60? Well, I multiplied it by 6, so I've got to multiply the 7 by 6 above the line. 7 6s are 42, and here's your answer. Ooh, squiggly lines there for sure. So doing that operation gives you 50 over 60 minus 42 over 60. You just rewrite the 60. You know that's the way it's going to be. 50 minus 42 is 8. And now you can simplify it. And you've got a beautiful answer just there. 15 divides into 60. Sorry, 4 divides into 60 15 times, and 4 divides into 8 twice. So 2/15 is your simplified answer. That's the third step just over here. Exercise 7.07, and again I say, nicely set out for you. Have a go. It's so important to cement your knowledge from previously, and as I said before, the last two, let me just press the right button, these last two are often the hardest. So if you can do the easy ones just up here, drop down to the bottom ones and have a go at those, and if you can do them, then you know that you'll be pretty confident in any assessment. I have included the answers on the very last slide so that you don't have to consult the textbook or anything like that. This little presentation is absolutely complete in itself, so you can mark your work by going to the last slide. Some more practice. Have a go, as I say at the top. Nice exclamation mark there. Have a go, and this is practice subtracting. So again, if you can do it, don't do it forever. just write me a little note, say, Mr. Hell, I'm moving on, and then I know that you're absolutely confident in this section of work. These word problems are very important, and I'd like you to give them a go. It's very important to be able to read the language of English, read the clues that you are given, and be able to interpret those clues and then identify fractions in there, identify questions in there, be able to set out your fraction, and then be able to use your mathematics, your knowledge of mathematics, to solve them. This is what makes math so very, very practical, young people. It's not some airy-fairy abstract subject up there in the sky. It has practical application, and we use it in everyday life. So have a go at these, and make absolutely sure that you are able to identify the mathematics in these questions and set them out. If you are stuck, please ask me for help. If you are stuck, please make absolutely sure you come and ask me. Don't struggle in silence and then walk away from these word problems. Come and ask me, please.